Well, we have another question here. Question 6. Well, the question says that the diagram below, A and B are the x-intercepts of the graph of f of x equal to x cubed minus 2x minus 3. A straight line G through, excuse me, through A cuts f at C and the y-axis at 0, 1. M is a point on F and N is a point on G, such that Mn is parallel to the y-axis. Mn cuts the x-axis at T. Now, question 6.1 says, as we can see over here, 6.1, the question says that show that g of x equal to x plus 1. Now, g of x is the equation of the straight line that we see here. So now we need to prove that it is equal to x plus 1. I'm going to write the question over here. So 6.1, so we need to prove that g of x equal to x plus 1. All right. Well, the fact that the graph cuts 2 points here at C and also the y-intercept here, notice the coordinate of the y-intercepts are like 0, 1. So we have 2 points with 2 points. We can write the equation of the straight line, okay? So we know that the equation is of the form y equal to mx plus c, where m is the gradient of the straight line, and then m is given by the change of y, okay, over the change of x. So we can work out the gradient m. This will be y2, which is 5, okay? I choose this one to be my second point, and this is my first point, the second point. So y2 is 5 minus 1. Okay, we have like 5 minus 1 over x2, 4 minus 0. Okay, so it's going to be like 4 minus 0, and then this is equal to 4 over 4, and then that is equal to 1. Therefore, we can see y equal to 1x, okay? 1x, and then what is the value of c? C here stands for the y-intercept, okay? This is the y-intercept, it's the y-int. And then we can notice that the point that we see here, this is the y-intercept. So we can just say 1x plus 1, or just y equal to x plus 1. Proven. In case you are unsure, you can just write y equal to 1x plus c. Now sub in any points, okay, in the straight line. You can sub the point 4, 1, okay, sub 4, 1, sub c, the point 4, 4, 5 in y. So this will be you sub 5 for y, and then 4 for x, and then this will be 5 equal to 1x plus c, and then this would make like 5 equal to 4 plus c, and then if you move the 4 over, that would make 5 minus 4 equal to c, and then c equal to 1, which implies that y will be equal to 1x just x plus 1. So it's another way you can solve it. But as for me, I'll go for the first one. Now, the following question is question 6.2. The question says that calculate the coordinates of A and B. So let's see. A is the point here, and then the B is another point there. Both are the intercepts, okay? The x-intercept of the parabola of f of x. I'm right here, question 6.2, looking for A. We know because this x-intercept, meaning the y value are 0, okay? And B is, call it like x1, and that's x2. So we're looking for a coordinate of A and B. Now, what can I do then? So we're going to set the equation of the parabola equal to 0. The equation of the parabola f of x is given by x squared, okay, minus 2x minus 3. If this is what we wrote, this is what was given here, fx, x squared minus 2x minus 3. Now, because, as I said, because A and B are the x-intercept, meaning the y value, f of x is just the y value, okay? F of x is just y. I prefer to write y here. So because they are in their intercept, we're gonna set y equal to 0. Okay, so it's gonna be like 0 equal to x squared minus 2x minus 3. Now we can solve this by factorization. I want to take the value. Okay, I am going to, because the leading coefficients here of x squared just 1. Now I am going to consider the constant term -3. So I write a -3. And then the factors of -3 are just 1 and 3. Now, the following question is this: which how can I get a sum of -2 from this couple here, 1 and 3, from the factors of 3? This is possible if we have like +1 and the -3, because 1 minus 3 makes -2. And then +1 times -3 makes -3. Then over here, I can just say 0 equal to, open bracket, x plus 1, and then x minus 3. Now, you know, in situation like this, for this product here, we can just make x plus 1 equal to 0. So if I move the 1 over, I move this one over, and then this will become x equal to -1, and then x minus 3 equal to 0. So if I move this -3 over, and then this will make x equal to 3. So those are the coordinates of A and B. Now, which one is A, which one is B? Obviously, A is -1, because you can see A is lies on the second quadrant. So A is -1. Over here it's -1, and then B, that lies on the positive side, on the first quadrant, and then B here is 3. Now, the following question is question 6.3. The question says that determine the range of F. Well, you know that this is a parabola, okay? F of x is a parabola. So now, this parabola has a U shape, meaning it has a minimum value. So it's all the values that are at least the minimum value here. Let's prove it. We are going to calculate the minimum value, which is the turning point, the x coordinate of the turning point. Okay. Let's just put the point there. The x coordinate of this point. Actually, oh, excuse me. They say the range. Okay, the range. Yes, we're gonna find the x coordinate of the turning point, and then say all the values that are at least that value. Okay, and then I wanna move my board over here, and then let's just split like that, and then we have like question. I'm gonna write here question. Okay, we'll do this way, and then let's do question 6.3. So we're looking for the domain of F. This is how I abbreviate it. So the domain of F will be we're gonna find. We are required here to find the minimum value or the turning point. So it's going to be x turning point is can be calculated by doing minus b over 2a, or also x of the turning points can be x1 plus x2, okay, all over 2, the average of the intercept, the midpoint between the intercepts. Okay, so because f of x is given by x squared minus 2x minus 3. If I use like the first formula, x equal to TP, this will be minus b, okay, over 2a. and then you can notice that the two negative signs here will cancel out, and then 2 and 2 will be simplified. So negative and negative here makes positive, and then 2 and 2 simplified, and then we have like x is equal to 1. Or someone else may use the intercept, this other formula. You can also calculate it like this. X turning point will be, the first turning point we got was -1, and the other was +3 all over 2. And then this still make equal to 1, because -1 plus 3 is 2, 2 over 2 is 1. Now that we got the x coordinate of the turning point, we can substitute this value into the function to get the y value. Remember that f of x, as I said, is just y. So this is like y equal to x squared minus 2x minus 3. And then we're going to sub in there the value of x. So wherever we have x, we're gonna put in 1 there, and then this will be y equal to 1 minus 2 minus 3, and then y equal to -4. Okay, I just wanted to find the turning point. So this is the y coordinate of the turning point is 1, -4. But in actual fact, when we find the x coordinate of the turning point here, we will say we find the y coordinate of the turning point. Remember this this -4. Excuse me. I meant to write this symbol, the range of f, not the domain, but the range of f. Okay, the range of x is all the acceptable y value. So once we find x equal to once you find that x equal to 1, we sub 1 over here, okay, and then we got the y value, which is -4. So we will then say therefore the range of f is y equals to greater than -4. You can check it out here. Okay, it's all the values that are more than -4, because if it's lesser than -4, it's outside the range. Okay, so -4 upward, -4, -3, and then up to there. So that's the range of f of x. Now, the following question is question 6.4. Over here, the question says that if m if mn equal to 6 units, mn, where are them in the graph? Okay, this one. If this length here equal to 6 units, now question 6.4.1 says that determine 6.4.1 was saying determine the length of OT. Okay, so the length of OT is OT is here. Determine the length of OT if T lies on the negative x-axis. Show all your working. So T obviously lies on the negative x-axis then. Now, so the question says that if mn is 6 units, okay, we need to find OT. I'm gonna move my board over here. For sake of 6.4, we're looking for OT. If mn equals to 6 units. Now, just for sake of clarity, I prefer to represent the same diagram over here again. Let's just put the graph over here. Okay, here's the graph. Now we are looking for OT, okay, this length here, if the length here MN, I mean MT, excuse me, no, that was, okay, if N is, okay, let's just highlight it like this, Mn is all this, okay, if this is equal to 6 units, how can we do that? Okay, we are going to determine the coordinates of t in order to work out OT. But before we find t, we need to find also the coordinate of n, okay? Because n and t share the same x coordinates. They're in the same straight line. Now, this is what we're going to do. Let's equate mn in, let's equate m and the length m. Okay, first of all, mn being a vertical line, okay, being a vertical line, we can just say m lies on the parabola over here, and then n lies on the straight line. So we can say the parabola is given by y, actually, x squared minus 2x minus 3. That's the equation of the parabola, and the straight line is given by x minus 1. So we do like the highest point minus the lowest point, okay? And then we can substitute the value of mn, it's just 6 units, and this will be equal to x squared minus 2x minus 3 minus x plus 1. Okay, when you drop the bracket here, the sign changes. The sign of whatever inside the bracket changes. So this becomes negative x and that positive 1. Now this will be, I'll move this 6 on the other side of the equation, and then this will be like 0 equal to x squared minus 2x, okay, minus 3 minus x plus 1 minus 6. Now let us underline like terms. So 0 equal to x squared. Is there any other term with x squared? No. Now let's look at the terms with x. So we have like negative 2 and negative x. That makes negative 3x. And then we have like negative 3 and negative 3 there, negative 6 there. And the positive 1 also, because all these are just they're just constants. So this would be equal to what was the equation of the straight line again? Was that x minus 1? Let's double check. No, it was x plus 1. Okay, that was the equation of the straight line. So over here it's plus, and then there it's minus, then minus here. So negative 3 minus 1 minus 6, that makes minus 10. Now we have like this then. Since the coefficient of x squared just 1, all we can do, we can just place in x in the bracket like that. Okay, and then look at the last term, it's negative 10, right? I'm gonna write here negative 10, and then that lists all the factors of 10. They are like 1 and 10, 2 and 5. Then we're gonna look at the couple. Which couple among the factors of 10 will make a sum equal to the coefficient of the middle term, negative 3. Now let's see which couple will. 1 and 10 will never make negative 3, but negative 2 and positive 5 will, if I put negative 2 over here and positive 5 there, and then this will make what? X minus 2 is 0, or x plus 5 is 0. So this will make x equal to 2, or x equal to negative 5. Now we have like the two solutions here. So the coordinates of t is just 2. Okay, so now the length OT, actually, I think I put, it's actually positive 2 here, positive 2 and negative 5. Yes, because positive 2 minus 5 makes negative 3. The sum here makes negative 3 and the product makes negative 10. So it's positive 2 here and negative 5 there. And then here we have like negative 2. Obviously, this side must be negative because we're on the negative sides of the x's. And it generates also a positive 5 there, but that's what we care about. So our answer is this one. And then this other one is not applicable, NA. Okay, so therefore, can write here, therefore, OB is 2 units. Remember, the distance must always be positive, okay? Even if you generate a negative answer, if you go 2 meters forward and 2 meters backward, it's still 2 meters from the origin. Doesn't matter. Now, the following question is question 6.4. Let's see. We have a question, let's see, question 6.4.2. That was 6.4.1, now 6.4.2. The question says that henceforth, write down the coordinates of n. Well, if we look at in our diagram here, n lies on the straight line, okay? And then the x coordinates, they share the same x coordinate as t. So we can just substitute this value in the equation of the straight line. We find it was x plus 1. I'm going to do it over here. To split it like okay, 6.4.2. We're looking for the coordinates of n. Okay, like in the previous question, we already got like x was negative 2, and then we need the y coordinates. Now, the straight line, the equation of the straight line was given by x plus 1. Okay, this is equation of the straight line of the straight line. Okay, and then we sub in negative 2 instead of x. Okay, we sub negative 2 there, and then y will be equal to negative 2 plus 1. This is just negative 1. Therefore, the point n is negative 2, negative 1. So we got n. Now the following question must be question 6.5. Over here, what does it say? Question 6.5, the question says determine the equation of the tangents to f drawn parallel to G. All right. I'll move my board like this. Uh, 6.5. So we're looking for the equation of the tangents. Remember that's the concept of the tangent line is a straight line, okay, of the form y equal to mx plus c. Now, it is said that that tangent line is also parallel to y equal to x plus 1, the straight line. So let me just put comment here. This is the tangent line. And then that is the straight line. The given, let's call it g of x. G of x. Okay, I think for sake of clarity, I prefer to represent the same diagram over here also. Okay, I'm gonna place it here. Let's see this diagram. Now we want a tangent, wants to find the equation of the tangent line to f, the parabola. Okay, that is excuse me. That is parallel to f. Excuse me, parallel to G. Fine. what are the conditions? So we ask ourselves the condition to have parallel lines. We know that the condition is this: two lines are parallel, okay, if the gradients are equal. So we need to prove that the gradient of first line equal to the gradient of the other line. Then in this case, we have like the gradient of the tangent line is must be equal to the gradient of the straight line. So therefore, y will be equal to the tangent of the straight line is just 1. So that's going to be 1x plus c. Now we need to find the point c. How can we do that? Okay, just to give a precision here, mt, as I said here, mt equal to 1, okay, because of this one. Now, what else to find c? Remember that the tangent line is the line that touches the graph at exactly 1 point. So we need to find that point. Then how can you do that? Another formula we know is a property about the tangent line is like the derivative of the function, okay, is equal to the gradient. So in this case, the derivative of f must be equal to the gradient of the gradient of the line. So this must be equal to 1. So f derivative, f of x is like x squared minus 2x minus 3. The derivative must be equal to 1. So let's differentiate this. Okay, remember the derivative formula is given by, like, you know, if you have like a x to the power of n derivative, this is like n times a times x to the power of n minus 1. Okay, so over here we're going to differentiate each term of whatever inside the brackets. So this will be like 2 times x to the power of 2 minus 1 minus, remember, if you don't see any exponents on the x, understand it's 1. Okay, so this will be 1 times 2 times x to the power of 2 minus 1, and then the derivative of any constant, no matter how small or big it is just equal to 0. So the derivative of -3 is just 0. This must be equal to the gradient 1. Now this would make what? 2x minus 2 equal to 1. Okay, we can now find the x value. If we move, that makes 2x equal to 1 plus 2, and then 2x equal to 3, and then x will be equal to 3 over 2. So this is the x coordinate at the points where we have the tangent line. Now we're going to find its corresponding y value. You know, a point is given, the point has both x and y value, right? So let's find the other coordinates of at this point. So we're going to sub in. We're going to sub x equal to 3 over 2 in the equation of the parabola in f of x. So this will be y equal to x squared minus 2x minus 3, and then that makes y equal to x squared minus 2x minus 3. Let's sub in the value of x, 3 over 2, and then y will be equal to 3 over 2 to the power of 2 is 9 over 4 minus this makes 3 minus 3 also. So this makes like y equal to 9 over 4 minus 6. Now that makes y equal to 9 over 4. Okay, we have 6 there. We can just write over 4 and then times 4 there, because we want to write them with a common denominator. Okay, so it's going to be like minus 24 over 4. The fact that the two term has the same denominator, okay, this make y equal to negative 15 over 4. So now we have the value of y, the y coordinates of the point of contact, between the parabola and the tangent line. So therefore we can find the value of c that we're looking for here. Okay, so we sub in y is 15, negative 15 over 4. Okay, I prefer to write like in this equation, y equal to 1x just x plus c. So we're going to sub in the y and x values. So now negative 15 over 4 equal to x value is 3 over 2. So equal to plus c. So if I move the 3 over 2 over, that makes 15 over 4 minus 3 over 2 equal to c. Now, if again, as I did over here, I need to set these two common denominators. So I'll times here by 2 and then times there also by 2. So this will be negative 15 over 4 minus 6. Minus 6 over 4. Okay, and you know, equal to c. This is equal to c. Let's just do it over here. That will make negative 21 over 4 equal to c. Therefore, the equation of the tangent line that is parallel to the parabola is then y equal to x minus 21 over 4. Done. Well, excuse me. Now, the following question, equation 6.6. Let's see, what does it say? Question 6.6. It's over here. Question 6.6 says what? For which value or values of k will f of x, okay, and h of x not intersect, excuse me, which value for the two equation will not intersect? Okay, this is just a 1 mark question, so we don't really need to do more calculations here. So in this situation, because we did find that the two graph, the graph tangent to the tangent line to the parabola is given by x. Okay, I say y equal to x minus 21 over 4. Okay, let me write it over here. Because we proved that the line of the tangent line to the parabola is given by x minus 21 over 4. Now, k here will then be must be lesser than negative 21 over k. So I'll say here k must be lesser than negative 21 over 4. If it is lesser than that, the two graphs will never meet. One will just come like somewhere, they will never meet. Thank you. Okay. Or maybe before, I just want to illustrate the parallel line then will be something like, okay, because x is like, we did find that x was 3 over 2, which is somewhere there. So the tangent line was something that looked approximately like this. Oops. Okay. So if k is lesser than negative 21, this line will go a little bit down this way, you see, and then the two graphs will never meet. Okay, thank you.